These badges were handed out at OpenSauce, and I figure I will pull a big Clive and reverse engineer this thing. So I will go over how I'm going to do that, and I also have the data sheet for the transistor that was used for this. It is called out as the PN2222 transistor right on the badge. I don't actually know anyone who purchased the components for these. I don't think I saw many people walking around with these things populated. So I will go ahead and simulate this in Circuit.js after this as well. So I'm going to start with the battery. I know it's a 9-volt battery. It's listed right on the board. So the circuit symbol for that is these two lines, sort of like a capacitor here. Following that, I know that we've got two LEDs that come right out of this, just like so. And I believe there are two resistors here as well. And I can beep that out with a meter or just have a look at the circuit itself. I will go ahead and pull out a multimeter and put it in continuity mode. Just to double check, I'm starting on the positive rail. I've got continuity here and here at the two positive pins of each LED, and I have continuity here on the 47 kilo ohm resistors and nowhere else. So I've got my two 47K resistors over here. There's one and two. These are 47K. LEDs. So, going to now hit the transistors. We come across the resistor and go to the middle pin of the transistors. That is the same on both sides. So the middle pin of the transistor is going to be the base, which I will do like this. These are NPN transistors, or BJTs rather. And if I'm not mistaken, the emitter, pin 1, connects right to ground. I can have a look at my little symbol right here, which has my pins denoted, and I can take a look here. So I can see that pin 1 is going to be the, yes, connected to ground on both of these, which I will simply denote with a ground symbol like that. Next up, I can figure out what connects here. Looks like these are going to be the LEDs. I will buzz that out as well here. So I know that I need this guy, which is going to connect here and anywhere else. Not yet. So there's then a 470 between here on both sides. Just double check. Yep. And this 470 goes to here, and this 470 goes here. So I will just jump over that. Jump over that. I'm going to go around whatever. We'll clean that up a little bit later. In addition, there's also 47 microfarad capacitors. Looks like one of these is between the base and the positive hits the... Where does the positive go? So the positive on this side connects to the collector of this one. I guess I should denote what these are. So we'll say that's left and that's right. This is once again left and this is right. So there is a capacitor that connects the gate here. Wow, this schematic is awful. Whatever, I don't really care. To the collector here, so I can actually just sort of throw that in there. pretty awfully. A-okay by me, doesn't really matter. And then I imagine that the other one does the exact same thing. Yes, so we're gonna come here to here. Yes. So then I will put this right here. That is truly awful. And those are 47 micron. I'm gonna see if I can't clean this up just a hair, make it look a little prettier. That's the reverse engineering done at least, so I have some semblance of a schematic. But this should be cleaned up a little bit, and I will have a look at that and see what I can do to make this a little prettier. But I will do that on the computer. Here is that as it stands. I'm gonna go make that up on the computer now.
And here's a cleaned up version of the circuit. We can see it's just a simple oscillator, specifically an Astable Multivibrator. It's astable because it has no stable state where the output isn't oscillating. The circuit works through the charging of the capacitors. As one capacitor charges, it causes its associated BJT to turn on, which turns off the opposite BJT. The cycle then repeats, with the opposite capacitor beginning to charge. This cycle repeats at a frequency specified by the 47 kiloohm resistor and the 47 microfarad capacitor. Changing either of those two values will change how fast the circuit oscillates. Hopefully this was useful or interesting.